In this video, video number 4 for acids and bases, we're going to talk a little bit about the pH scale. We drew a picture of the pH scale and we talked about what it means to be an acid and a base the other day in class. But here we just want to go a little bit further. So on the pH scale, it's going to tell us how strong an acid or base is. Remember, an acid is anything less than 7, a base is anything greater than 7, and when you're smack in the middle of 7, you're neutral. You're a stronger acid when you're closer to the lower end of the scale, meaning that you produce more hydrogen or hydronium ions. And bases, like the strength, goes up as they get closer to 14, the higher end of the pH scale, the more hydroxide ions they produce. Any solution, we could talk about the concentration of hydrogen and hydroxide ions. If the concentration of hydroxide ions is very high, we say alkaline. Alkaline solution is basically basic. If there's lots of OHs, it's very basic. If there's lots of Hs, hydrogen ions, we're going to say that's a very acidic solution. So water is going to, when we break up into ions, hydrogen and hydroxide ions. A neutral solution has an even amount of hydrogen and hydroxides. We talked about how when you're an acid, you have more hydrogens, and when you're a base, you have more hydroxides. But when you're neutral, you have an even amount of each. So for pre-IB, the Kw for water, since it's the same amount of hydrogens and hydroxide, would be 1 times 10 to the negative 14th. And this is the ion product constant for water. Reagents, you don't have to worry about that. So we should know that if there's more hydrogens, meaning you're going to be more acidic, and here, if you're more basic, you're going to have more hydroxides. We talked about the fact that pH is based on logarithms which have a base unit of 10. So every time you move on the pH scale, you're not changing by a value of 1, you're changing by a factor of 10. If you go down the pH scale, becoming more acidic, you're increasing by a factor of 10 every time you move, like so 10 times 10 times 10. Every place you move towards increasing hydrogen ions, and you're decreasing hydroxides. When you go up the pH scale, every place you move, you would multiply by 10, increasing the amount of hydroxides that you have. We talked about the pH is equal to the negative log of the hydrogen ion concentration, and that when you plug the value in, like 1 times 10 to the negative 7th as the hydrogen ion concentration, the pH comes out to be the positive value of whatever it is that you were looking at. So if this is a negative 7 exponent, the pH would just be 7. So it says, what's the hydrogen ion concentration of a solution? If it's the hydrogen ion concentration is 1 times 10 to the negative 10th, the pH here would just be 10. So since the pH is negative log of the hydrogen ion concentration, the pOH will tell us the power of the hydroxides will be negative log of the hydroxide ion concentration. It works the same way. So what's the pOH of a solution that has a hydroxide ion concentration of 1 times 10 to the negative 3rd? That would be 3. For any solution, the pH plus the pOH is going to be equal to 14. So what's the pH of a solution that has a hydroxide ion concentration of 1 times 10 to the negative 3rd? If the hydroxide ion concentration is this, the pOH, the power of the hydroxides, will be 3, so the pH would be 11, because 11 plus 3 will get us to 14. Okay, this is asking us what's the pH of this solution. It's not written in scientific notation. Move that decimal 1, 2, 3, 4, 5 places to the right. It would be 1 times 10 to the negative 5th. Since it's 1 times 10 to the negative 5th, the pH would just be 5. So here they're asking what's the pOH. It's 1 times 10 to the negative 3. The pOH would be 3, which means the pH would be 14 minus 3, or 11. Next, just fill in your acid-base scale just like you did in the notes. You have acids all the way to the left, bases all the way to the right, indicate the strength and weaknesses of them. And I just want you to note that you're moving over by a factor of 10, so multiply by 10 every spot you move on the pH scale. Okay, so here's a typical Regents question. An acidic solution could have a pH of, we just have to pick anything that's going to be a pH under 7. So the answer here would be 3, because it's the only one that's under 7. 7 is neutral, 10 and 14 would be basic, indicate the basic solution. And last, an acidic solution could have a pH of, same idea. Oh, that's the same one. Hold on one sec. Okay. An aqueous solution has a pH of 1 times 10 to the negative 8. If it's 1 times 10 to the negative 8, you just make that exponent the value of the pH. So the pH would be 8, and then 8 is above 7, so that means it's a base. So the answer to this question would be choice 3.